The Effect of Forces by Natalie Rompella. The Nature of Forces. How many objects do you apply force to every day? Do you ever push a door open? Do you grab or pull any objects? When you push or pull something, you are applying force. Force is a push or pull. Forces push or pull not only when objects touch, but even when they do not. Have you ever held two magnets near each other and then let go of one? The magnets may have attached to each other. The magnetic pull was the force that pulled and held them together. When you hit a ball with a bat, you are actually pushing it. If gravity did not pull the ball down, it would never fall on the ground, or it would be very difficult to catch. Applying forces. Objects receive force from many different directions. They also apply force on other objects. What determines how something moves? The greater force causes an object to move. If it receives the same amount of force in opposing directions, it will not move. If two people of the same mass push with the same force on opposing sides of a box, the box will not move. If one of the two people applies more force, measured in newtons, the box will move away from him or her. If you have ever built anything with wood, you may have held the pieces together with nails. As you applied force to the nail with a hammer, the force pushing the nail down was greater than the force of the wood pushing back, and the nail moved into the wood. Understanding friction. Let's say you take off your shoes before going into the kitchen. As you walk over to the refrigerator in your socks, you slip on the floor. Why? The flat surface of the kitchen floor and the smooth surface of your socks cause little friction with each other. Friction is the force that keeps objects from moving past one another. Now think what it would be like to ski with too much friction. Your skis would not slide past the snow easily, and you would not ski very quickly. What happens if you decide to walk in your socks on the carpet? You probably will slide less than you did on the smooth kitchen floor. The carpet's rougher surface creates more friction with your socks. The type of friction that the carpet and your socks make with each other is called sliding friction. There are two other types of friction: rolling friction and static friction. Rolling friction resists an object from rolling over a surface or other object, such as trying to inline skate on a carpet. Static friction resists an object from beginning to move, such as trying to slide your bed or another piece of furniture across a room. Once you get it moving, it becomes easier. Using and avoiding friction. You rely on friction every day. When you wash your hands, the soap helps to kill germs, but the motion of rubbing your hands together also creates friction, which helps to get rid of germs. People who play stringed instruments, such as violins and cellos, know that friction can be a good thing. Before playing the instrument, they rub a special substance called rosin on the bow. Rosin is made from tree sap and makes the bow stickier, creating more friction with the strings. Gymnasts also use rosin on their hands to help keep their grip, especially on the uneven bars, balance beam, and parallel bars. Can friction be harmful? Did you ever get a blister from a pair of shoes? The shoes rubbing against your feet, or the friction between your shoes and skin, caused the blister. Have you ever seen potters making a clay pot? They allow the clay to spin as they work it with their hands. They keep their hands moist with water to avoid friction. They want their hands to easily slide across the surface of the clay to smooth it into a particular shape. Gravitational force. The force of attraction that is experienced by all the objects in the universe is gravitational force. Gravity is the gravitational force on Earth. Jump up. If you try to stay up in the air, you can't. Why? Gravity pulls you toward the surface of Earth. Gravity holds the water in the oceans and holds the air near Earth. Gravity has an effect on the growth of plants. Life depends on gravity in many ways. Earth is not the only source of gravity, however. There are other gravitational forces in the universe. In the 1600s, Sir Isaac Newton discovered the properties of gravity. He explained that gravity depends on the masses of the objects. Objects with greater mass exert more gravity on objects that have smaller mass. The magnitude of the force not only depends on the mass of the objects, but also on the distance between the two objects. When you jump up into the air, you pull on Earth with gravitational attraction. The Earth is also pulling on you. Because Earth has a much greater mass than you do, its gravitational attraction is stronger, pulling you back to the ground. At a higher altitude, gravity is slightly less. Universal force. Newton was the first to realize that the force holding any object to Earth is the same as the force holding the universe together. Which do you think has a greater gravitational force, Earth or the Moon? Because Earth has a larger mass, the Moon is pulled toward Earth and orbits Earth. Which do you think has a greater gravitational force, Earth or the Sun? The Sun has a much greater mass than Earth and all of the other planets in the solar system. That is why the planets revolve around the Sun. They are being pulled toward the Sun as they orbit it. Also, each of the planets has a specific gravitational pull. Although your mass would not change if you traveled to different planets, your weight would. That is because weight is a measure of a planet's gravitational pull on you. Weight in the metric system is measured in newtons. If your mass is 50 kilograms, your weight is 490.3 newtons on Earth. The table above shows the weight of a child who has a mass of 50 kilograms. The differences in weight are due to the fact that every planet has a specific gravitational force. If she could weigh herself on each of the planets, her weight in newtons would change due to the differences in gravitational force on each planet. If walking on the Moon, she would weigh 83.5 newtons, or 18.8 pounds. The Moon's gravity is about 1/6 the gravity on Earth. The effects of gravity. Have you ever looked at the shoreline by the ocean? Sometimes there is a lot of beach, and other times at the same place there is less. This is because the level of the ocean water varies over the course of a day. This is due to gravity. Both the Earth and the Moon have strong gravitational attraction. The Moon's gravitational attraction causes water to be pulled away from the Earth toward the Moon. When this happens, we experience high tide on that side of the Earth. At the same time, the side of Earth opposite the Moon also experiences high tide. The Moon does not have as strong a pull on the opposite side of the Earth. Rather, this bulge of water is caused by the movement of the Earth. While the sides towards the Moon and opposite the Moon are experiencing high tide, the two sides in between are experiencing low tide. Describing motion. Have you ever been sitting in a car at a stoplight when the car next to you slowly starts to move, and it's hard to tell whether you are in motion or the other car is in motion? If you look at a nearby tree or street sign, you can tell which is really moving. An object that can be used to detect motion is called a frame of reference. Usually, Earth is used as the frame of reference for motion. When on Earth, one can tell which object is moving in relation to Earth. But isn't Earth moving? It is. But we are moving with it. At dusk, many people will sit outside to watch the sun set. In reality, Earth is rotating away from the direction of the sun, making the sun seem to disappear and then reappear at dawn. Kinds of motion. Objects can move in many directions. Motion can be straight, zigzag, curvy, or even up and down. Trains and airplanes move mostly in straight lines. Many sports use straight motion. Golfers usually try to hit the ball so that its motion is straight. When you bowl, the ball rolls down the lane in a straight line too. A zigzag motion is moving in a line that sharply and repeatedly changes direction. Some skiers train to move very fast through gates that are positioned in a zigzag pattern. Some skillful skiers are able to do this easily. A curvy motion is traveling in a line that is not straight but moves in a smooth, continuous fashion, such as walking up a spiral staircase. If you've ever watched cars race on a circular track, you may have described the car's motion as curved. However, from the frame of reference of the drivers in the car, they would probably describe the road's motion as curved. Think of a child on a seesaw. The movement is up and down. To the child on the seesaw, the ground is moving up and down. To someone watching the child on the seesaw is moving up and down. Calculating speed. An object in motion moves at a certain pace in a given time. Speed is a measure of how fast an object is traveling. If you run 1 kilometer in 10 minutes, your speed would be calculated by dividing the distance by the time. Usually speed is measured in kilometers per hour. To calculate speed in kilometers per hour, first calculate the speed in kilometers per minute, and then multiply by 60. Distance of 1 kilometer divided by time of 10 minutes equals speed of 0.1 kilometer per minute times 60 equals 6 kilometers per hour. Your average speed would equal 6 kilometers per hour. However, you probably would not run at a constant pace of 1 kilometer for every 10 minutes. There would probably be points when you would run a little faster or slower. The speed that you are traveling at the exact moment is your instantaneous speed. Animals travel at different speeds. One of the fastest land animals is the cheetah. Cheetahs can run as fast as 100 kilometers per hour. Peregrine falcons are able to dive down to catch prey at a top speed of 440 kilometers per hour. Snails, on the other hand, travel only 0.048 kilometers per hour, making them one of the slowest animals in the world. Greyhounds, zebras, ostriches, and gray foxes all move at about the same speed of 64 kilometers per hour. Although cockroaches are small, they are known for being quick. They can travel 5 kilometers per hour. Some of the fastest humans are able to run at speeds of 37 kilometers per hour. Through the years, humans have tried to decrease the time it takes to travel by creating machines with faster speeds. More than 200 years ago, the first steam locomotive was invented. Since then, automobiles, airplanes, and rockets have been created. One of the Wright brothers' original airplanes flew at a top speed of 68 kilometers per hour. Today, airplanes are able to travel at speeds of more than 1,000 kilometers per hour. Finding velocity. Many objects can move at many speeds and in many directions. Velocity is the speed and direction of a moving object. A car traveling from New York to California may have a velocity of 80 kilometers per hour west. On the return to New York, it may have a velocity of 80 kilometers per hour east. The velocity of an object not traveling in a straight line will constantly change. Think of a snake that slithers in a curvy line. Although its speed remains constant, its velocity changes each time it switches directions. The wind can change the velocity of an object. If you've ever flown a kite, you've seen how both the speed and direction of the kite can change. Sailors rely on the wind to navigate their sailboats across the water. They need to know the direction and speed of the wind to arrive at their destination. The force of the wind against the sail helps the sailboat to move through water. By rotating the sailboat's direction and speed can be changed. Acceleration. Do you like to ride your bike? As you begin pedaling, you apply force to the pedals, and you begin to accelerate. Acceleration is the rate at which the velocity changes. Acceleration can be both increasing and decreasing velocity. You come to a busy street, so you apply the brakes, causing friction between your brakes and the tires, and between the tires and the road. As the bike slows down, your velocity decreases over a period of time. A decrease in velocity is called deceleration. The velocity of an object only changes if a force acts on the object. If you roll a ball across a floor, eventually the velocity and speed of the ball will decrease. Gravity and friction, among other forces, will slow the ball down. If you roll a ball down a hill, the velocity will change, and the ball will accelerate due to the force of gravity. Studying motion. During the 2nd century A.D., an astronomer named Claudius Ptolemy believed that the planets and the sun circled around Earth. It was not until the 1500s that another scientist, Nicholas Copernicus, came up with a different theory. He believed that the planets, including Earth, circled around the sun. Through the years, scientists have studied force and motion. Many scientists have conducted experiments to help figure out their theories. Some of the major scientists who have worked on force and motion are Galileo Galilei and Isaac Newton. Galileo studied the properties of gravity. Newton is known for the 3 laws of motion. First law of motion. If you set a book on a stationary surface, such as a table, it will remain there, assuming no other forces act on it. If you push the book with your hand, the book will move across the table. This is what Newton named the first law of motion. An object will remain at rest unless acted on by an unbalanced force. The opposite is also true. An object will remain in motion unless acted on by an unbalanced force. A child on a swing will keep swinging until a force, such as gravity, stops the swing. Another force that can change the motion is friction. Inertia is another name for the first law of motion. Inertia is the tendency of an object to remain at rest, or in a continuous motion, unless a force acts upon it. The mass of an object can affect its inertia. If you set one textbook on your desk, you can easily push it to the other side of your desk. If you were to stack 10 textbooks on top of one another and try to push them, it would be more difficult. The stack of 10 textbooks has a greater inertia, making it harder to move. Second law of motion. A child can easily pull a wagon. What if the wagon were filled with heavy rocks? It would be more difficult for the child to pull it. This is Newton's second law of motion. The acceleration of an object depends on the mass of the object and the amount of force applied. In the wagon example, the mass of the wagon changes when rocks are added. To move the wagon, more force is needed. If an adult helped to pull the wagon, more force could be applied, increasing the acceleration of the wagon. Using an equation. To find the acceleration of an object, divide the force by the mass. Force can be measured in newtons. Acceleration equals force divided by mass. If a child uses a force of 10 newtons to pull a wagon with a mass of 23 kilograms, the acceleration would be 0.43 meters per second squared. The direction of the acceleration depends on where the unbalanced force is coming from. In a game of tug-of-war, each team depends on its collective mass and force to help pull the opposite team, forcing it to cross the line dividing them. Whichever team exercises a much greater force will achieve a greater acceleration, which will cause the other team to move in the direction of that unbalanced force and cross the line. Third law of motion. What makes trampolines so much fun? They put into practice Newton's third law of motion. When a force is applied to an object, the object exerts an equal force in the opposite direction. You push down on the trampoline and then bounce back up in the opposite direction. Stretching a rubber band and releasing it is another example of this law. As you pull the rubber band, you are exerting a force on it. As you let go, the rubber band flies off in the opposite direction from which you pulled it. Try to jump straight up in the air without bending your knees. Were you able to jump very high? Now bend your knees before jumping. Did you get any higher? Dancers know the importance of the third law of motion. Before they jump high into the air, they bend their knees. This force in the opposite direction helps them jump higher. Basketball players also use this law to help them slam dunk. They run, bend their knees, jump, and go soaring toward the basket. The basketball, too, is an example of the third law of motion. As the player dribbles the ball, applying force to it, the ball rebounds off the floor and bounces back up to the player's hand. This law is also called the law of action and reaction. An action, such as throwing a ball at a brick wall, causes a reaction. The ball bounces back. Because the wall has a greater mass than the ball bounces back, and the wall hardly moves. If a ball is thrown at a glass bottle, such as at a carnival event, the glass bottle may be knocked down if the ball has a greater mass than the bottle. Momentum. After a batter hits a baseball, the player's body continues to swing around. Why? The amount of force needed to stop the ball and make it go in the opposite direction takes momentum. Momentum depends on the mass and velocity of an object. The mass of the bat and the direction and speed of the hit need to be greater than the mass and velocity of the ball. When objects collide, the total momentum before the collision equals the total momentum afterward, known as the law of conservation of momentum. The total momentum before the batter hits the ball equals the total momentum after. The more momentum the ball being pitched has, the harder it is for the batter to hit the ball to make it first stop, and then change its direction. The universe in motion. A force is a push or a pull. We can measure force and identify its direction. Some forces act only if the objects touch, such as when you hold a book in your hand. Other forces act even if the objects do not touch. Earth's gravity pulls you down when you jump. Friction is the force that resists the movement of an object over the surface of another. Gravitational force is the force of attraction between objects in the universe. Every planet and moon has a different gravitational force. The force depends on the size and mass of the object. Gravity on the moon is much less than on Earth because the moon is smaller. Motion is described using a frame of reference. You are not in motion relative to Earth when you are sitting quietly. But because Earth moves in space and also rotates on its axis, you are moving with Earth relative to the Sun. If an object moves faster or slower, the change in velocity is called acceleration. Motion can be described by specific laws. Newton's laws explain how things move in the universe. Though we do not notice it, the Earth moves through space at a speed of 29.8 kilometers per second.